All right, good morning. It's time to move on to the next chapter. We are now done with the first one. Test is over, and it's time to move into some stuff about matter. So you should have already written down and handwritten the notes concerning the properties of matter, and you should have submitted that to me so that I saw that you had it all written down. Now what we're going to do is we're going to go over those notes. And again, these notes look like this, right? Properties of matter. So that's what you should have already written down in your notebook. And as you watch this video, you should be adding to your notes so that you have stuff. As you notice with the last test, I am making it so that your tests are open note. So obviously then it's really important that you have extra stuff on your notes to help you take the test. So on these first notes, you'll notice that it talks about matter. And what is matter? Matter is anything that has mass and takes up space. So what are some things that are around you that are made out of matter? Well, the computer that's in front of you has mass. It does take up space, so it's matter, right? So is the pen or pencil that you might have in your hand or nearby you. The chair that you're sitting on right now. Let's see, what about the door to the room that you're in right now? That's all matter. All of that is matter. Now, a question I have for you is, what about the light that's coming out of the light fixture right now that's near you? Is that light that's coming out, is that matter? Does it have mass? Does it take up space? One way to look at it is, can I grab it? If I can grab the light, and can I go like this and go, look at that, see that light? Oh, you can't see it. There's no light. It just came out of my hand. I didn't grab a hold of any light. So the light is not matter. Instead, what it is, it's energy. All right? And we can actually take everything in the entire world, actually everything in the entire universe, we can put into two categories. We can say it's either matter or it's energy. That's the two things. If it's not matter and it's not energy, then it's nothing. And there's nothing there. Right? Even I'll jump back for a second. What about this stuff right here? Air. What is that? It's matter. I can grab a hold of it. Right? I can stick it inside of a balloon. I can stick it in the tire of my car. So it is actually matter. Right? Even though we can't see it, it is still matter. It does have mass and it does take up space. All right, so going along with that, in letter B, and we talked about this in the last chapter, and I put it in this one also because it's something that is so commonly misunderstood, and that is the difference between mass and weight. Remember that mass is how much matter something is made up of, right? I'm made up of a certain amount of matter. I actually have matter that makes me up, right? Now, one way in which we measure that is we measure it based upon the pull of gravity. And the gravity pulling down on me, when gravity pulls down on me, that's weight, right? Now, what if I was up orbiting the Earth where I am weightless and I have no weight? That means I am not experiencing gravity, or at least I can't feel the gravity. Because I can't feel the gravity, then I feel like I'm weightless. Am I still made up of matter? Yes, I am still made up of matter. So I still have mass. It's just we can't measure it using weight at that point because I'm not being pulled down by gravity to be able to measure that unit. So remember, mass is what you're made up of. Weight is the pull of gravity. And then there's the third one that also gets mixed in there, and that's letter C, and that is volume. And volume, how much space do I take up? How much space does a cup of water take up? Right? That's the third thing that, again, is mixed into this. So we've got mass, amount of matter. Weight is the pull of gravity on that. And then we got volume is how much space the object takes up. Now, one way that I like to describe on that is think of which one has more mass, right? Would it be, all right, let me rephrase, I'm sorry, I said that wrong. Which one would take up more space? A ton of bricks or a ton of feathers? Which one takes up more space? It's going to be the ton of feathers. That's going to be a gob of feathers to get a ton of them, right? A ton of bricks, that's not even going to fill back into my truck, right? So that's going to be this little bitty small pile to get a ton of bricks. But a ton of feathers, it's going to probably fill my entire room to try and get them. So there's going to be a big volume to get all that mass and all that weight of a ton of feathers. So that volume, again, is space. Now, what is a substance? Well, substance is matter with the same composition throughout. Substance is kind of like a generic term for a lot of the things that we're going to talk about in this class. Way I like to describe this is if I told you go to Walmart, get me a bottle of ketchup. Well, probably one of the things you're going to ask me maybe is you might ask me and go, well, what kind do you want? Because you go into the aisle where all the ketchup is, and man, there's a half a aisle full of ketchup. Because there's Heinz ketchup, there's Hunt's ketchup, there's Great Value ketchup. If we go across the road, there's Meyer ketchup. There's the Golden Tomato ketchup. There are so many different brands of ketchup, right? But are they all ketchup? Yeah, they're all ketchup. So that's like this generic term for ketchup. But we can be very specific and say Hunt's ketchup, Heinz ketchup, right? So a substance is like the generic term for a lot of the stuff that we're going to talk about in this course. And it's anything that is the same all the way through the entire thing, right? So elements, that's a substance. Compounds, those are substances. Solutions, that we'll talk about later in this chapter, those are a substance because they're the same throughout. Excuse me. Something that's not a substance would be two types of mixtures that we're going to talk about later, which would be a suspension and a colloid. Because those two are not the same throughout, so they would not be classified as a substance. Instead, they are a type of mixture. Excuse me, goodness. All right, well then, trying to identify different types of matter or tell the difference between matter, there's two properties that we need to look at. And those properties are, the first one is called physical properties. And what physical properties are is those are things that you can observe. They are characteristics about it that you will collect using your five senses. I can feel it, right? I can see it, I can smell it, I might taste it. So you can utilize your senses. You might be able to hear it. So to get those characteristics. Some examples on that is, how do you tell the difference if you go into a store if I'm buying silver or gold ring? Well, you're going to use a physical characteristic. You look at it and go, well, does it look like gold or does it look like silver? You're just using a physical property, one of your traits, to be able to tell. Another physical thing you could do is you go into the store and you buy some chips. Are you buying regular chips or are you buying barbecue? Well, how are you going to tell? Well, you could look at it. That would be one way. You could use that physical property. You could taste it. That would be another way. You might even be able to smell it and smell the difference, smell the barbecue versus no barbecue. So you're using physical properties to tell the difference between them, right? So some things that I listed on there: color, solubility, does it dissolve in water? Odor, what's it smell like? Hardness, is it really, really hard? Is it really, really soft? The melting point, boiling point, ooh, those are different, aren't they? The melting point of water is a very specific temperature. The water melts at 32 degrees Fahrenheit, or because we're in science and we use metric, it would be 0 degrees Celsius. That's when it melts if we're going up. If I'm going down, if I'm taking the temperature down, as we're noticing outside, starting to do that way, then 32 degrees Fahrenheit or 0 degrees Celsius, that's the point at which the water freezes, right? And it's always that temperature unless we do something to that water, which again we will talk about later in this course. Boiling point, same idea. If I take that water up high enough, I can go all the way up to 100 degrees Celsius, 212 degrees Fahrenheit. That is the point at which the water will boil, right? Unless we do some specific things to it, which we'll talk about again later on in this course. Those are very specific, and I can actually utilize those properties in order to identify what something is. I can also use that to actually separate substances, which we'll again talk about later. Density, in the last chapter we talked about the density of gold. Its density is 19.3. If I measured out a gold item that I find inside the parking lot, which was on one of the worksheets in the last chapter, if the density of that object was 19.3, was it gold? Yep. And on one of the worksheets, we found something, and I gave you the data, and we measured it. Was it gold? No, because it was way less than 19.3. I said it was fool's gold, right? Which is a substance that looks just like gold, but it's not gold. All right, the final thing on this, I did also put down the equation for density, which we talked about in the last chapter. But remember that density is mass divided by volume is a way we can figure out density. Last thing on physical properties is physical properties do not change a substance into anything new. It stays exactly the same way. If you look at an object and look at gold and silver and see its color, you're not changing that thing. It's still going to be a gold ring. It's still going to be a silver ring. Right? My titanium ring still looks titanium, kind of a silverish color, but it's not silver. Right? But it's titanium. So water excuse me, to identify that it's a liquid and what it feels like. You're not changing it in any way. It's still water, right? What about if I melt ice? Did I change it into something new? No, when it was ice, it was water. When I melted it, it became water. It's still water. I didn't change it into anything new. Even when I boil it, when I take water and I boil it, it goes from water to steam. It's still water, right? That water goes up in the air and it sits up there. And then like our weather that we have every so often is that water actually condenses. It comes together and makes water droplets, and then it falls to the earth in the form of liquid water. But when it was floating around, it's actually water. It's still water. Right? We haven't changed it. All right, the other properties are chemical properties. In the case of chemical properties, I think what I'm going to do now at this point is I'm going to stop this video and we're going to go on to part number 2. And part number 2 is going to be the chemical properties. So make sure you go watch part number 2.